In section 2 of chapter 2, we're now discussing ions and ionic compounds, and the learning objectives you should achieve from this particular section is the ability to define an ion, list some common ions in the body, differentiate between cations and anions, describe how charges are assigned to ions, describe, or I should say define an ionic bond, describe an ionic compound of sodium chloride, and list other examples of ionic compounds. Chemical compounds, in terms of ions and ionic compounds. There are stable associations between two or more elements combined in a fixed ratio, and they're classified as either ionic or molecular. And those ionic compounds are structures composed of ions, which, if you remember, is a charged atom. It's held together in a lattice by ionic bonds. And here we have an example of such a lattice for sodium chloride here. The lattice is held together by the strong attractions between the positively charged sodium and negatively charged chloride. Okay, and the reason why sodium is positively charged, typically speaking, is sodium has the number of protons is 11, and so therefore the number of electrons is 11. And if you remember, that initial layer always has no more than 2. The initial orbital of electrons has 2, and you keep going out till you finalize the number of electrons in this particular in the atom we're talking about. In the case of sodium, which has 11, would have 8 on its second layer and would have then just only 1 on its outer third valence, its outer shell. And so it basically wants to give it. So it wants to give that last electron to get down to 10 electrons, and they would have now 11 protons, making it positively charged with 1 extra proton. Whereas a chloride, which essentially is 17 protons and electrons, and it wants to get, ideally, because it's actually the higher number of electrons, it actually wants to be able to basically to gain 1 to become negatively charged. So it wants to get to 18 because it wants to get to 2 on the inner layer, 8 the next layer, which is what sodium now is. Sodium is now stable, and then it wants to get its outer layer, chloride, because it was at 17, wants to get to 18. Whenever it's 5, 6, or 7 electrons, typically speaking, an atom will try to get to increasing the number of electrons, whereas if it has 1, 2, or 3 on its outer valence, it'll try to give them away. Okay, and then thus becoming positively charged, where the ones that are higher with a higher number of electrons in its outer layer and its valence is going to try to become negatively charged by gaining more electrons to balance out, to get to its outer, fulfill the octet rule and get 8 in the outer valence, outer layer. Okay. Now, atoms with a positive or negative charge are ions, and they're produced from a loss or gain of 1 or more electrons, like we've just been mentioning. Some significant physiological functions occur in that situation. Potassium, which basically a K+, because it wants to get rid of an electron, it eventually then becomes positively charged by getting rid of its last electron, its outer valence, and it often becomes a K+, which then makes it an active ion and positively charged. It's often used for sports drinks to replace potassium lost. It's also in large doses used in some states for lethal injection because you don't want to get too much potassium. It would take an awful lot to do that, but in a concentrated dose, yes, it could be fatal and not a good thing. So let's not take straight larger amounts of potassium. That being said, losing electrons in the formation of cations, okay, to be negatively charged. Sodium, basically, or I'm sorry, positive charge for a cation. Once you lose an electron, you're now positively charged, right? Because you went down 1 in minus, and now you're up 1 in plus. Sodium can reach stability by donating an electron, like we just said. Sodium likes to get to that plus because it has that 1 electron in its outer layer, that one getting it back down now ideally to 10 electrons where it wants to go, or where it's going to try to go. Consequently, it's going to end up with a charge of +1. It'll go from what's originally an Na to an Na+, which you've seen before with a superscripted plus here. And cations are ions with a positive charge. So as we mentioned here with that, talking about that sodium, whereby it's got 11 protons, 11 electrons, so it has 1 electron in the outer layer, it's going to want to try to, typically speaking, get rid of an electron, and ends up being positively charged when it has 10 electrons and 11 protons. Whereas chloride, which binds well with sodium chloride, salt, right? And you're going to end up now with it at 17. It wants to try to get to 18, so it wants to add an electron and become negatively charged, okay, which works well for sodium and chloride to bind because you have a positive and negative charge to balance, right? Whereas sodium has one extra electron, one remaining on its outer layer, on essentially its fourth layer, excuse me. it's got 2 and then 8 and then 8 and then 1, right? And it wants to try to get rid of that, and it's why it often becomes positively charged, like we just showed a moment ago. Calcium, we aren't really talking about specifically a lot, but if you think about it, it's got 2 extra on its outer layer, which means it's also more likely to give away, try to give away its 2 remaining electrons on its valence to try to get it to be typically, as it often is, positively charged, okay, when it becomes a calcium ion. So gaining electrons, the formation of anions, chlorine, as we just mentioned, reaches stability by gaining an electron. It has 17 protons, it gains an electron, basically getting it to 18. So basically, it's going to now be negatively charged, and it's now an anion because it's negatively charged. Cation, a positive charge, anion, negatively charged. Polyatomic ions are anions with more than 1 atom. Very common in chemistry. You'll see not such a basic recognition of just Cl- or Na+, but more specifically some like a bicarbonate ion and phosphate ions, which are natural buffers in the blood. We now have is hydro. Basically, we have the hydrogen, we have carbon, we have oxygen, and we have HCO3 minus negatively charged, and a phosphate ion also negatively charged because they're both anions, right? And we basically have phosphate and an oxygen, and we have 4 oxygen, 4 of the oxygens, and then we have 3 minus, right? Got -3 electrons, basically 3 more electrons than protons with that polyatomic ion. Ionic bonds, these cations and anions may bind together by electrostatic interactions. Those interactions, those we should say those interactions are electrostatic, and those electrostatic interactions are called ionic bonds. Okay, they also form salts, and table salt, obviously the one that's very commonly referred is sodium chloride, common table salt, and we just already mentioned this. Each sodium atom loses the outer shell electron to a chlorine atom, so we end up with a positive for the sodium, the negative for the chlorine, and they bond together quite well to form the ionic compound known as table salt sodium chloride. And magnesium chloride, same thing. Magnesium loses 1 electron to each of the 2 chlorine atoms, so it's actually going to basically give away 2 electrons to make chlorine negative, and magnesium becomes positive. And here we can see that same interaction more from a pictorial representation, showing you how sodium's got that 1 outer layer, that valence where it's got just that 1 electron, wants to give it away, gives it to chloride, because chloride's got 7 on its outer layer, wants to get to 8, so it makes a very nice balance, making them both stable to form sodium chloride. And of course, then you show it's showing the sodium in the purple and the chloride there in the green. Okay. So what did you learn? You should be able to list common cations and anions in the human body, including their name and symbol, and there are quite a few. On the periodic table, by looking at the periodic table, really, finding out, determining what is more, what is going to be positively or negatively charged from ion, most likely to become an ion or a cation, an anion, sorry, going to be an ion either way, but an anion or a cation depending upon whether or not it's closer to wanting to give one away or to gain, right? And on the periodic table, she will highlight then the elements that form the common ions of the body, which a lot of tables already highlight for you. But you should be able to go through and do that now and explain how and why ions form based on the octet rule. Remember, it wants to get to 8 in the outer layer, so it's trying to get there. And if it's a higher number of electrons in its outer layer and its valence, it's going to try to gain electrons. If it's lower, 1, 2, 3, it's going to try to get rid of them and become positively charged. Okay. And of course, last question, could an ionic bond form between 2 cations or between 2 anions, like 2 positives or 2 negatives? It's going to need to be, it has to be balanced, right? It's got to be one has basically an electron trying to give away, the other one trying to gain, and that's when those bonds form, okay? And we'll come back to section 2.3 in just a moment.